All right, so good morning, everyone. My name is Fransisco Martua, and today I'm going to show you my mathematics presentation. So here's my question. In this case, I'm asked to minimize equation y is equal to x1 plus 4x2, subject to x1 to the power of 0.25 and x2 to the power of 0.75 is equal to 10. All right, so first thing that we're going to do is we are going to determine which one is the objective function and the constraint function. In this case, the objective function is the function y, and then the constraint function is the other one. After this, we're going to create the Lagrange equation by adding up both function, but then the constraint function must be multiplied with lambda. Right, so after we find the Lagrange equation, the step one is to find partial derivative with respect to each variable. In this case, we have three variables, x1, x2, and lambda. Here's the answer. And then after we find the partial derivative, we equate them to 0 and then make lambda as a subject to cancel it out. All right, so in this case, the first lambda is equals to -8 over as such, and then the second lambda is -16 over such thing. The question is, where do I get -8? -8 is from there. 2, I put 2 to the right and then divided by 0.25, which will gives us -8, and then I move 4 to the right, -4 over 0.75. I simplify it to become 16 over 3. Okay, and then once we found the equation for both lambda, we equate them together, which will give us a new function, and then I do simple cross multiplication. Then the end result is 3 over 2x1 is equals to x2. Now we found x2 is equals to 3 over 2x1, and then we substitute the original equation to be like this: x1 to the power of 0.25, and then this should be x2. But then since we already know x2, we substitute it with 3 over 2x1, and then with simple algebra, I get x1 is equals to 7.38 and x2 is equals to 11.07. After we found both value x1 and x2, we're going to substitute back to one of the original function of lambda. In this case, I use the first one. And then here we have the lambda is equals to -5.9. The lambda is going to be, we're looking for lambda here because it is going to be used for the next problem, which is the Hessian matrix determinant. All right, so in order for us to find the maximum or the minimum, we're going to use the Hessian matrix, and then we're going to know it from the determinant of the matrix itself. So as Pak Irwan have taught us previously, this is the way to create a matrix. We have F11, F12, G1, F21, F22, and so on. So I'm just going to tell you like what does F12 means. F12 means we're going to derive dx2 with respect to x1. So here is the matrix itself. And then since we already know the lambda and the x1 and x2, we're going to substitute everything to find the exact value. And so I substitute everything already, and then this is the value. And then since this is a 3 by 3 matrix, this is the way of finding the determinant, the last two steps. Yeah, after calculating it, we get the value of the determinant is -0.16. And then since we know that the determinant is less than 0, we can conclude that this is a minimum. Thank you very much.